Okay, so method of joints is probably the simpler method for evaluating trusses in terms of like the complexity of the math. But once you get into questions that ask you for members in the center of the truss, it kind of gets mathematically cumbersome because you have to end up jumping from like the corner and then joint by joint all the way to the middle. But if they're asking you for the internal forces on all of the truss members, or if they're looking for one that's like right next to the edge, then you don't necessarily want to do method of sections, if that makes sense. So the premise is you know that the net force at each pin on the truss has to be 0 because the truss is not moving, right? So every force at that pin has to balance out. But because you're evaluating it at the pin, you only have 3, or you only have 2 unknowns because it's a concurrent force system. So you can only use some of the forces in the x direction and some of the forces in the y direction because essentially there's no moment. So the moment equation would be useless. So that's why looking at this example, you can solve it, and looking at this example, you can't, because here you have 3 unknowns, and, or because at joint B here, you have 3 unknowns and only 2 equations. So that wouldn't be able to be solved. So looking at the one that can be solved, how would you do it, right? So the first step is to find the joint you want to look at and then draw its free body diagram. So I already have the free body diagram drawn out here. The only thing I'm missing is this XY indicator thing. So I've done that. I have my forces, my dimensions. I will draw in a second. So that would be, we'll call it 2 meters. And this will be, we'll call it 4 meters. I don't know why, arbitrary. So that, and then my labels, I have already A, B, and AC. So then I would want to find all of my external reactions first, but I'm assuming that my external reaction is 100. So if you had a support at any of these locations, it would have to be found before you can start solving it. And then let's see, you isolate the one joint where there's less than 3 unknowns. So I have joint A, I have 2 unknowns, A, B, and AC. And then I use my equilibrium equations to solve it. So I can look at the sum of the forces in the y direction. I'm calling up positive equals 0. So I have a negative 100 newtons. And I know that this here is 2 and 4. So this would be the square root of 18. So if I'm looking at the y components, I would say plus AB, because it's going up, times 4 over root 18. And then I would solve for that, and I can solve for AB. And then looking at my x equation, I know it's equals 0, and I'm going to call the right positive. My only force is AB times 2 over root 18, because there's a chunk of that going to the right. And then I have plus AC, because all of that goes to the right. And then I can solve for AC. So once I've used my equilibrium equations, I then jump to the next joint, right? So you really only use method of joints if you have to solve for several more, right? So if I find A, B, and AC, which joint would I move to next, B or C, based on how they're drawn? Well, I would want to move to joint C because as it's drawn, B has 3 unknowns exposed, right? Whereas C only has 2. So I have 1 here and 1 here. And then I can use this one, this vertical one, because I know those will be equal. And then I can solve joint B because then I'll only have this one and this one. So you kind of have to just jump from joint to joint, knowing that you can only go to ones that have two unknowns exposed. So that is essentially the premise of method of joints. And then this one, I would really only recommend using if you can't use method of sections, or if method of sections wouldn't really help you. So as you can see, if I have to do all of this math, every single joint, getting to the ones that I am asked for, getting to the members that I'm asked for, it's not really helpful because of the amount of math I have to do. It's possible, but it's not really helpful. So I would really only recommend using method of joints if you have to solve for forces that are really close. If I'm only asked for this member, this member, this one, and these two, then that makes sense because it's just 6 separate equations that I have to solve to get through all those. But if I'm asked for something that's like all the way over here, and there's like 9 joints between there and where I have to solve, that's not really helpful because then I have to solve 18 equations before I get to the ones that I care about. Whereas I might just be able to cut it somewhere over here and solve it in 3. So it kind of depends on the situation. But yeah, so that's method of joints.